G'day guys, welcome back to the channel. Here I've got a quick unboxing to do. I thought I'd do it on video, let you guys see. Received a new piece of equipment for the lab today. I don't know if anyone saw that sticker on the top of it, but that might give a little bit of a clue away as to what's in this box. Right, here goes. So what I'm going to be doing with this, I'll show you my dim bulb setup in a minute. I think I might have actually shown that in another video, but it's a new variac. I had to do that on the floor. I'll put this up on the bench now, and then I'll move you guys back up to the bench. My apologies, I just did not have enough space to fit the box on the bench and still give you guys a decent view of what's going on here. So there it is. Aussie plug. Let's see what the fuse is. What have they put in here? 3 amp. Yep. 3 amp fuse. It doesn't feel right. Yeah, how cheap is the fuse holder? Okay, that was me. That was me. Alright, I'll take that one back. Don't like the screws, but whatever. Alright, let's plug it in. And have a quick look. I do like the digital screen idea. That's pretty good. Just one moment, I'll just plug this in. It's nice. Oh wow, you can wind it right down and it's actually displaying pretty well. Wow. You know what? I wasn't expecting that before I wind it up. I'm curious actually how accurate that is, especially down in the lower region. Yeah, not accurate at all. I didn't expect it to be. Oh, it's actually out by a bit. It's not too bad. As I thought, yeah, it gets better as you wind it up. Alright, let's see what we got. 260, 256, right. That's all the way up. Wow, 350. 341. So 340 volts. I'm happy with that. It says 0 to 300 and it actually goes up to 340. I wonder how much that drops under load. It says 345 and it's 340, so it's out by 5 volts. Okay, it's not too bad. Gets worse down the bottom end, but hey. I mean, the main thing you want this for is just to turn it up and down. You're not really that focused on the exact voltage, and if you are, you probably got a meter on it, so that screen's more than fine for now. I know what I use for a load. Oh no, that's too big. What should I use as a load? I'll just unplug. I'll go get something and I'll come back, sorry. Okay, I'm back. I grabbed this old Bosch Cool. It's rated at 3 amps on the label, so let's see. How much voltage does it drop? Sorry about the noise. Doesn't look good when you're putting an inductive load on it, the way the panel meter kicks up there. It really shows the inductive kickback. Yeah, I'm actually quite happy with that. Yeah, that would have, when I was putting the load on the drill just then with my hand, that would have, still have just a little bit more actually. I don't hurt my hand. My hands are really shiny. Yeah, and he dropped about 5-10 volts under full load. I'm impressed. Obviously I haven't left this thing on and you know, like put it under a load and seen how hot it gets. I'm just having a look at the windings through the case and they honestly do look pretty small. But it should be alright. I mean, I don't plan on using this thing at a high current. What I actually have got it for is to, I don't really have space on my bench, so I'll just grab the camera so I can show you guys. It's going to go down there on the floor because my lab power is just coming in off a cable off the wall and then just being split up around the lab with power boards and cables. And my dim bulb setup, which I'll just go over if, I don't know if I've actually gone into detail on this before or not, but basically all those bulbs are 25 watt bulbs. Just little 25 watt bulbs. And each one of them, as you can see, can be switched on or off. So on, open, on or open. Not, those switches don't bypass the bulbs, they just literally add them all in parallel or open. And then, set neon. So this switch over here, this is the main power. And this switch over here, this is the bypass. I know it's a bit hard to see, there's a switch there. That's to bypass all the bulbs. And I've also got some banana jacks with a neon across it just to indicate that it's live, and the 2 sockets on the front of it. So that's my dim bulb box. It's quite a cool box. Excuse me, I really went over on building that, but I wanted something that was around about 200 watts, switchable in about 25 watt steps. So, and I wanted a couple of power points on it, I wanted banana jacks on it, so I just went and got a big plastic box, and yeah, that's what I did. So this is going to sit down there in front of this huge ass transformer that I built one time. Anyways, that's going to sit on the floor down there, and that's going to go into my dim bulb box, and then I'll have control over the voltage and how much power I'm limiting with the bulbs. I mean, it's obviously it's not like having a constant voltage, constant current power supply, but as everyone knows that works with stuff, just having a dim bulb's helpful enough. You've seen how good the dim bulb setup I've got is, so I think you can all imagine with this going into that, I have some pretty good control how it brings stuff up, especially if I'm worried about old capacitors, or I've just worked on something and I'm worried about a switching component blowing up or something because there could be more problems or whatever it might be, you know, like these devices will help a lot. A lot of times with working on switch mode power supplies, for example, you can't use a dim bulb because it won't let enough current flow for it to actually start up properly, and it will just go into a loop mode. Sometimes some of the controller ICs have got like 0 point crossing detection and stuff like that that helps them control the PWM to the switching devices. And if you mess up or screw up the sine wave a little bit, which a dim bulb can do as the voltage drops all of a sudden and raises again as the capacitors charge up through the limited current flow through the lamp, and then the power supply tries to turn on and the capacitors drop. Stuff like that can actually wreak havoc occasionally and cause controllers to screw up, and for an example, like turn the low side and high side fit on at the same time and blow the whole supply out. It's rare, but it does happen. So having one of these guys can be really helpful for working on stuff like that, because I can set my dim bulbs up to a higher wattage than what I'm doing when I don't have one of these. So instead of like putting 50 or 75 watts in series with a power supply and it might not be enough, I could put the dim bulb on, say 100, 150 watts and bring this up to a lower voltage, like 90, It's just going to give me a little bit more control. Maybe not 90 through all those bulbs, maybe somewhere around 120, but you get the drift. It's going to give me a lot more control. I'm just noticing something. Oh, that's the input current. Okay, all good. Wait, is that the output current or the input current? It doesn't. Oh, that's right. This thing's fused to 3 amps. It's not actually 3 amps, is it? Because it's 500 watts, 0.5 kVA. So 300 times 1.7. Yeah, that maths out. Cool. So I'm happy with that. 500 watt variac. That's that. The other thing I wanted to show you guys, because I've done a video on my component collection, but what I have missed in it, I wanted to just go over some of the logic ICs, because I've got a strange collection of logic ICs. I got random drawers. I've just got stuff like CD series ICs and HCF and HEFs and stuff like that, just like scattered around the place. There might be some more in here. No. And then there's more random chips. I should have charged my phone up so I could put the flash on. There we go. You can see a bit better. A couple more logic ICs in here. And then, what's in here? Whole load of SN74121s, okay. But then I still got to organise all these. This is all, some of it's new, some of it's old. And when I say old, I mean really old. This is all 74LS, 74HC series. I've got some packages in here that are that old. It's literally like some sort of ceramic sandwich package. I don't know how to explain it. I'll just grab a couple of the really interesting old ones and we'll bring them back over to the bench and have a look at them. And I'll grab a couple of modern day ones too, and we can have a look at the difference between them. And why not something from in between? So, alright. So, as I was saying, nowadays if you look at logic ICs, they're probably going to look like this if you go and buy them. Sorry, it took a minute to get that to focus. If you went back maybe to like the 90s, 80s, you'd probably find stuff would look a lot more like this. if you go back to early 80s, 70s, check this out. Some sort of like, I don't even know if that's plastic. I think it's some sort of ceramic with a different type of ceramic like cement inside it. I think they basically put like, I guess the silicon dye in there and all the bond wires in some sort of goop and then sandwich it together. But yeah, I just thought I'd give you guys a look at that because they're really old school. And you know what? Oh, where is it? I've actually got some really cool chips to show you guys on that note. Okay, here's another example. I didn't do this actually. Someone gave me a whole load of components and in it was this, like an apron or whatever. But someone cut the pins off. But you can see the dye in it. That'll make for a good video. Isn't that a thing of beauty? Intel 77. Look at all the bond wires. It's a shame someone cut the pins off. You could theoretically just reattach pins. There's enough there. And then look at this one. It's a complete ceramic package with like a bit of gold that appears to be soldered to the ceramic. I can't explain that. I don't know how you solder to ceramic. I'll be honest, I've never tried to solder to ceramic. Why won't this focus? Sorry. Yeah. These are just some random ones from my collection. But yeah, I just wanted to give you guys a look at that. A little bit more of my IC collection and the variac that I've just bought. I still got a high voltage component voltage breakdown tester on the way to test like MOSFETs and IGBTs and thyristors and triacs and diodes and that sort of stuff. And what else? I've always got stuff coming because I'm in the middle of expanding my lab, so there's going to be more equipment videos coming. I can tell you guys that. Alright. That's all for now. I'm going to go and tidy up in here and then set up for a repair video because that's what's coming next. See you guys soon.